Hello there, calculus students. This is my review for 2.1 in our textbook, which is about quadratic functions and models. So before we get started, I thought I would highlight the key points. I want to talk about the definition of a quadratic. I want to talk about how you draw a graph of a quadratic. I want to talk about the standard form and vertex forms of a quadratic and various parts such as the axis of symmetry, the vertex, and the x-intercepts and y-intercepts. So that is the main goal for me right here. So without any further ado, the definition of a quadratic, if we think about a quadratic as being a subgroup or a small part of the family of polynomials, then you have to say, well, what is a polynomial? Well, polynomial, poly means many, nomial just mean terms, so it's got many terms, although in math, when we say many, we just mean one or more. So you could have a single monomial, and this would be a polynomial where you've got some number. It's any real number. That can be anything along a number line. Anything at all that you can find on a number line can go there as a coefficient. However, there are real restrictions on the exponent. The exponent must be a positive whole number. Now, if it's negative, it doesn't work. If it's 0, then it just poof turns into 1, and then you just have a constant term, and that's kind of boring. But typically it's 1, 2, 3, 4, 5, 7, 10, something like that, but it's whole number. This is what we would call our degree. So the degree is going to be the highest exponent value of all your terms. So a polynomial could have 10 terms, and if one was x to the 7th, then you'd say that's a 7th degree polynomial. Okay, so once you know what a polynomial is, then a quadratic, I have some things that are okay. Just to make it clear, this is a polynomial, one term. 3, that's on the number line, x to the 7th, that's a whole positive number. This is okay. All of these are okay. Notice these are all positive whole numbers. These are not okay. Not okay here because 1.7 is not a whole number. Not okay here because -3 is not a positive number. It's not okay here because x in the denominator is like raising it to a -2 power, just like the -3, that's not okay, so no x's in the denominator. Here, the exponent is not a whole number, and here, this is really square root of 5, and the square root of x, that's x to the 1/2 power, and if you were to multiply 903 by 1/2, it would not be a polynomial. If that was a 902, then it would be, because you could take half of 902. All right, so what is a quadratic function? A quadratic function is just a second degree polynomial. And so that's the key thing, that it's something that we can write where there's an x squared term. And usually we write it like this. That's how our book is going to do it, where you've got your a, your b, and your c that goes in, guess what? The quadratic formula. So that's an important thing for us to remember this year too. Now, it's funny because in my earlier classes at Pingree, I was told by my teacher that this is standard form, but our textbook, if you look, has standard form a little bit differently. They put it into what we normally call vertex form. So I think you might find that teachers might still call this vertex form, even though our calculus textbook will call it standard form. This is clear. I like vertex form because this will give you the vertex of a graph of a parabola. What you do is you just look at this and you say, when is this going to be 0? This is going to be 0 when x is 3, 1, 2, 3, and that is your axis of symmetry line. And then this will tell you where your vertex is. This is not in parentheses. You've got nothing to sub in to make 0. You just go up 5, 6, 7, and there you are at 3, 7. That is your vertex. Then this tells you that it opens downwards. And if you want to find a quick another point, you can go left and right 1 unit and down 2 in each case. It's a little bit like doing a slope. That only works one time, and it'll open down like this. But down here, it says, as an example, write the above as if it's in standard sort of polynomial form. Again, unfortunately, the book will call this standard form, and they just don't call this anything, I think. But we're going to write it in ax squared plus bx plus c form. And so all we do is we FOIL this out. And so we'd say this is equal to -2. If you FOIL that out, you're going to get x squared minus 6x plus 9 plus 7. If I distribute the 2 in there, I'm going to get -2x squared plus 12x minus 18 plus 17, or plus 7, sorry. And so my final answer is minus 2x squared plus 12x minus 11. So if I plug in 0, I'll get the y-intercept 5, 10, 11. And it looks like I'm pretty close to drawing it right. And I can just flip that point over. That's your symmetric point. This will be 6 then minus 11. This is 0 minus 11. And all that's left is to find these two x-intercepts, and we would just plug that into the quadratic formula using 2 for A, 12 for B, and 11 for C. And we don't have time to do that now. All right, but the next one is graph this. Well, this is not in this form that's easy to graph, not in old school vertex form, but we can make it be that way 2 ways. I'll try to do it 2 ways quickly. One is to complete the square. So we take and we write this and we factor out the 3, and we'd write 2x plus x squared plus 2x, I'm getting ahead of myself, plus blank minus blank, and then minus 13. What I'm going to do is I've rewritten this where I've created 2 spaces, one to complete the square and then to keep it balanced. I can't just pull numbers out of thin air. I got to also add the opposite right here. How do I complete the square? Well, this is a perfect square if it's x plus 1 squared. What do? I take half of that, that's 1, and I square it, and that's 1. And then when you factor that, you get this. If I add 1, I subtract 1. And if I multiply by 3, just like I would multiply by 3, this is all in parentheses, I would have then minus 3 minus 13. And so my final answer would be, don't forget the 3x plus 1 squared minus 16. And I could graph this just like I did this one up there. The vertex, find the vertex would be, when is this equal to 0, you ask? At minus 1. And this is the other coordinate then for the vertical shift. And so the vertex is at -1, -16. Okay? So the last question here is, find the quadratic function with a vertex of -1, -4 passing through 3, 2. Well, I know that my template is f of x equals a x minus h squared plus k. That's my vertex, and that's my aperture, how steep the quadratic is. All right, what do? I put in my -1, and this becomes x minus a minus 1. That's plus 1 squared. I put in my minus 4, and I know it's passing through 3, 2. So I just know that it's going to be 2 coming out. I don't know what a is, but I know what's going in is going to be 3. And now I just work out what a is. 2 equals 3 plus 1 is 4, squared is 16. 16a minus 4. Add 4 to both sides. 6 equals 16a. Therefore, a equals 6 over 16 equals 3/8. So my final answer will be f of x equals 3/8 x plus 1 squared minus 4. That is the equation for the quadratic function passing through 3, 2 with a vertex right there. All right, so I think some of that would have been chopped off. I hope that was still visible. There's a lot to review there. Hope that helps. Make sure I covered all my key points. axis of symmetry, that's this line right here. That can be found